Good afternoon. My topic this afternoon is integration by partial fractions under case number 4, repeated quadratic factors. Repeated quadratic factors, partial fraction, integration, guys. Okay, let's proceed. Case number 4 under integration by using partial fraction, repeated quadratic factors. Okay, I will try to bring out the form. f1 of x over f2 of x equal to, I will just read this one, then later on, as I give example, we'll go back to this. Okay, it will be a 2px plus q all over px squared plus qx plus r to the first power plus b over px squared plus qx plus r again to the first power plus c 2px plus q all over px squared plus qx plus r. This is first, so we will go with the second. Okay, second power. This is plus d over px squared plus qx plus r to the second power plus dot. The last part will be f 2px plus q all over px squared plus qx plus r raised to n. You see, this is n, okay? The last part plus f over px squared plus qx plus r again raised to n. We don't analyze for the meantime. As we bring out the example, we'll go back to this, okay? It's just a memorization of this one. Just take a look of the formation, then try to recall, okay? I will give you an example, okay, to analyze this problem here. Okay, example number 1. X cubed plus x minus 1 all over x squared plus 2 quantity squared, the integral. This is multiplied by the x equal to, what will be the value? Or meaning, evaluate the integral of x cubed plus x minus 1 over x squared plus 2 quantity squared dx. Try to observe the denominator. The denominator is a quadratic equation, okay? And the power is actually 2. So it falls under repeated quadratic factor. The denominator is a quadratic equation and it is repeated. So to bring out the integral of this, we must have to take first the equivalent of this in terms of partial fraction. How many? It will be 4. Because the highest power of the quadratic factor is 2. Okay? So for the first one, we got this 2 here. Hold on. That one. That will be the equivalent. That's for the first one. And for the second quadratic factor, we add another 2. This one. So actually, we got 4 partial fraction. 1, 2, 3, and 4. The unknowns are actually A, B, C, and D. To set up the equivalent partial fraction on the right, we will follow this. Okay? So, x cubed plus x minus 1 over x squared plus 2 quantity squared equal to, we will follow this. A. What's the derivative of the denominator? It's 2x, so this will be 2x. No more cube, okay? Plus b all over x squared plus 2 to the first power. This is the first quadratic factor. Okay? And for the second quadratic factor, it will be c, okay, times 2x again, all over x squared plus 2, will go to the second power. So this is quantity squared. We are now through with the first, right? So this is square. plus d all over x squared plus 2 quantity square. And this is the equivalent of the second quadratic factor. So actually there are four partial fractions on the right. Expanding this one, okay, we will multiply all terms by x squared plus 2 quantity square. What will remain on the left hand side will be x cubed plus x minus 1 equal to 2ex. 1x squared plus 2 will remain, plus b, again, 1x squared plus 2 will remain as a multiplier. For c, 2cx, x squared plus 2 quantity square will vanish, it will cancel out, so this is just multiplied by 1, plus d, the denominator is again will vanish, it will cancel out with the multiplier, right? So this is multiplied by 1. Expanding, this will be the resulting equation. Could you see it, guys? X cubed plus x minus 1 equal to 2ax cubed plus 4ax plus bx squared plus 2b plus 2cx plus d. This is the required equation on how to compute for the value of a and b. Okay? Let's proceed. We will expedite a little bit. My battery is almost gone. Equating coefficient of like terms. For x cubed, left hand side will be 1 equal to 2a. Therefore, a will be 1/2. X squared. 0 is equal to b. Therefore, b will be equal to 0. X to the first power, 1 is equal to 4a plus 2c. We now know a. Okay, so c will be equal to negative 1/2. X to the 0 power, or pure constant to the left and right, or by using this equation. Minus 1 is equal to d. This is it. Minus 1 is equal to d. Therefore, d is equal to minus 1. Therefore, the integral of x cubed plus x minus 1 over x squared plus 2 quantity square equal to, we will just follow this one, guys. Okay? This should be a times 2x over x squared plus 2 to the first power plus the value b, over, which is 0 over x squared plus 2 plus the value c. What is c? It is minus 1/2 times 2x. So we are following this. Over x squared plus 2 quantity square plus minus 1 over x squared plus 2 quantity square, close bracket, dx. The second term will disappear because this is 0 all over x squared plus 2, this will be 0. Okay? This is now integrable. We bring out 1/2, so this is 1/2. We expand, so this will be 2x dx over x squared plus 2. This is minus 1/2, we bring it out. The integral of x squared plus 2. This one, we bring it up to the minus 2, 2x dx. The third one will be minus, this is minus. Plus and minus will be minus. Minus the integral of dx over x squared plus 2 quantity square. This is natural logarithm. This is power formula. This is our problem. And we will use solve this by using trigonometric substitution. Just in case this is now integrable, we bring out the final answer. But for the meantime, we do not do the integral of this. This is now the one part of the final answer. 2. Let it be like that. I will go back to it later on. So we will try to take the value of the integral of dx over x squared plus 2 quantity square separately. Okay? Be systematic. The integral of dx over x squared plus 2 quantity square using trigonometric substitution. Just in case you don't see it. We let x squared equal to 2 tangent square of theta. Taking the square root of both sides, x now will be square root of 2 tangent of theta. Dx will be square root of 2 secant square of theta differential theta. Okay? let's try to compute for x squared plus 2 quantity square. X squared is actually 2 tangent square of theta, this one, plus 2. Then we factor out. This will be equal to 2 times 1 plus tangent square of theta. And this is secant square of theta. So this is 2 secant square of theta. If we try to compute for the value of x squared plus 2 quantity square, we will substitute this one inside. So this will be equal to, we'll just square this one. 2 square is 4, secant square is secant to the fourth of theta. Okay? Therefore, the integral of dx over x squared plus 2 quantity square equal to the integral of dx. What is dx? Dx is this. Okay? And the value of x squared plus 2 quantity square is actually this one. We place it under it. Right? We place it under it. So 1 secant square will cancel. What remains at the bottom will be secant square of theta. Okay? So this will be square root of 2 over 4. We bring it out. 1 over secant square will be cosine square of theta, differential theta, right? This will be square root of 2 over 4, the integral. We use the double function. We pass that under identities. Cosine square of theta is actually 1/2 times the quantity 1 plus cosine of 2 theta, differential theta. And this is now equal to the square root of 2. We bring out the 2 and the denominator, we bring it out, so it will be square root of 2 over 8, the integral of quantity 1 plus cosine of 2 theta, differential theta. Then try to distribute this one. The integral of the differential of theta is just theta. The integral of cosine of 2 theta, differential theta, u here is 2 theta. du will be equal to 2 theta, 2 differential theta. So we lack 1/2. So we place 1/2, and the integral of cosine is actually sine of theta. So the integral of this, the integral of cosine of 2 theta differential theta is actually 1/2 sine of 2 theta. So the final answer, okay, the final answer, we will copy this. 1/2 natural logarithm of x squared plus 2 plus 1 over 2 x squared plus 2. Okay, this is minus minus, so this will be plus now. Minus, this is minus, right? The equivalent of this, and by using the trigonometric substitution, it is square root of 2 over 8 times the quantity theta plus 1/2 sine of 2 theta. Okay, so the final answer will be 1/2 natural logarithm of x squared plus 2, okay, plus 1 over 2 times the quantity x squared plus 2 minus square root of 2 over 8 times the quantity theta plus 1/2 of sine of 2 theta plus c. Final answer.